Alright, so we're going to look at the product rules, everything out of our hands, because it's a lot easier if you're listening. So the product rule, with the chain rule, we use that when we've got a function inside a function. So we've got something like that to the power of 3 or that to the power of a half. With our product rule we're using, we've got a function multiplied by a function. Now in this example, what can we do? Do I need the product rule for this example? I can just expand them and solve. Believe me when I say that won't be the case the whole way down. Sometimes you've just got to use the product rule. So I thought I'd give us a nice kind example and we can use a product rule to solve that. The way the product rule works is we've got a function times a function. I label one of my functions gx or u and the other function hx or v. I'm going to show you both techniques because this is how it's commonly referred to, but this is the one that comes up in your formula sheet. It's relatively easy to go either way. The only issue with this is I don't know why we use u and v, because when kids write u and v on their formula, on their exam, they look very, very similar. It would have been good to pick a different letter, but we're stuck with u and v. And for the product rule, it doesn't matter which one goes first. There's another rule that you'll need to know where it does matter, but for the product rule, it does not matter which one goes first. So in this case, I can pick any of the functions, but by convention, I should probably pick the first function to be u and the second function to be v, or the first function to be gx and the second function to be hx. So which function is my gx here? X squared minus 4, and my hx or v is equal to x cubed plus 1. So I want you to look at the rule to the right and tell me what I'm going to be doing in a few seconds. Thinking. What am I going to be doing? Ryan, what do you reckon I'm going to be doing? So the derivative of my function is equal to gx times h word of h dash. What's that dash mean? So what do I have to do? I have to derive my hx functions. Over here, I'm going to derive h dash x equals, what's h dash x equal? 3x squared. Now you'll never guess what else I have to do. Derive my gx function as well. So g dash x equals 2x. Cool. So I've got gx, g dash x, hx, and h dash x. I then do what? Sub those in. I'm going to get rid of this rule here because we're not using that, but it's exactly the same. Nothing different about it, correct? Just so I've got a consistent flow of working. So now I've got, what's gx? X squared, take 4. What's h dash x? Plus am I done? What do I have to do? Expand it in. So I get 3 x to the power of 4 minus 12 x squared plus 2x to the power of 4 plus 2x. Am I done? Calculate higher terms. What have I got? 5x to the power of 4 minus 12x squared plus 2x. And that is dy dx. Well done, you've just learnt the product rule. Just to simplify what we've done here, identify the hardest part is knowing what rule to use. The rule itself is actually relative. This one's pretty gentle. We have a function times a function. We label each of our functions together. We find we write down each function, we derive each function, and then we show it into our formula. Cool? You'll find those on your formula sheet, but if you have to look at your formula sheet by the time you reach the final exam for that formula, you're in a bad spot. Cool? You will have used that enough that you know what's going on. So just to be clear on what we're doing now, in case we're a little bit lost, exercise 10.6 is what we were doing, question 2 to 4 and 8, and now we're doing exercise 10.7, question 1 to 3. We can get going.